What's the standard equation of a circle? The general equation. This is one of those things you don't want to have to look on a sheet of paper to look it up. In other words, you want to memorize it.
X minus h squared plus x minus k squared equals r squared.
Plus y minus k. And what are h and k?
X and y.
That's the center of the circle. That's the coordinates of the center of the circle. In other words, if you have a notice that in problem number 3, the center is at the origin. So h is going to be 0 and k is going to be 0. So the equation of this circle would be what? This is the general equation of a circle, and they want the specific equation of each of these circles that you're looking at. So
would it be 0, 0?
Well, yeah, it would be x squared plus y squared, not totally zeros. It's just that we're not going to subtract anything from x and y first. And then what's the radius of that number 3?
What's the equation?
No, what's the radius? We need the radius equation.
2. 2
So,
squared.
there's the equation of that first circle.
Well, that's it?
Uh-huh. Let me expand this a little bit. Let's do number 4, because that's a little harder. They're not, really none of them are hard. Circles are really quite easy. What's the center of the circle? What are the coordinates for number 4?
Coordinates for 4.
So where is the center?
It's 2, 1, 2, 3. 2, 3.
Okay. So what's h?
H is 2.
What's k?
3.
What's r?
2.
Okay, so what's the equation for this circle? That's kind of the way you should do every single one of them. Is figure out what x is, or h, figure out k, figure out r, and then it's just a question of plugging into the general equation. So what do I end up with?
X minus 2 squared plus y minus 3 squared equals 2 squared. So x squared minus 4.
There you go.
X squared minus 6.
You can do every single problem through 8 in this same manner. And none of them are harder than this one was. In other words, the next one's at the origin. This one has a center that's on the x-axis. This one has a center. You can figure out where that center is, and you can figure out where that center is. So once you locate the center and figure out the radius, that's the only difficulty there is in those problems. Now, let's go to 9. Rather than spending all of our time on these, you feel comfortable that you can do these, all of them?
Yeah.
Okay. Because if you don't, let me know. We'll do more practicing on them. The one thing I kind of realized after speaking with Mrs. Moore is that there really just isn't enough time in the day, because you go to class and you listen to your teacher lecture, and then you go home and you do homework, and then you have a tutoring lesson with me, and we get to do 1 or 2 of each type problem. What's needed after that, if you really want to get good at this stuff, is it's like a sport. You have to practice. In other words, that's not enough to just listen to your teacher and figure out how to do the problems with me. It seems like enough at the time, But what happens, and I think this happens with most all students, is that you might be able to do these problems today with me, but then a week from now you forgot how to do them. And the reason that forgetting takes place is just not enough practice. So if I could tell you anything at all, it would be that once, particularly when you're working with difficult problems, I don't know if you considered these difficult or easy, but, and they're going to get harder when we talk about ellipses and hyperbolas and things like that. But for stuff that's hard, that you're just grasping, you want to practice it. After you've figured out how to do one, don't let that knowledge waste away by not getting practice. To me, it's similar to if you're learning how to play golf, you take a lesson from the golf pro, but it doesn't do any good unless you then spend, you know, some amount of time practicing what you've learned from the golf pro. And math is quite the same. In order to lock in something that you're learning, you need to practice it. And I suspect that's the ingredient missing from most students that aren't getting good grades, is the practice ingredient. So notice that 9 through 14 are actually easier, right?
Mm-hmm.
Because you don't have to figure out where the center is. You don't have to figure out what the radius is, like we had to do on the 6 graphing problems. On 9, they give you the center and the radius. So what's the equation for 9?
X minus 0
So you can just write
squared.
Yeah, you don't need to write x minus 0. That just becomes x.
Oh, and y squared equals 49.
Correct. Okay, how about number 10? The key on all of these, every single problem is knowing the general equation. In other words, is all we're doing is we have a general equation to work from. Let me write it up here again. And we're just figuring out, they're giving us h, k, and r. So is all we're doing is plugging in h, k, and r into every one of these. So what's h in number 10?
-4.
So how would I write that?
Well, it has to be positive, so 16.
No, h is 4, -4. So it's x minus a -4. That's what goes inside the parentheses. And 2 negatives make a positive, so it's actually x plus 4 squared. What's the rest of it?
Plus y minus 1 squared.
Equals?
Equals 1 squared.
Just 1, yeah. In other words, they always want you to give the simplified answer. They don't want you to expand these out, but they want you to square whatever that radius is. You don't want to be giving an answer of 1 squared or 2 squared. Go ahead and do the squaring. Okay, so number 11. Well, let's do number 13.
Wait, I have a question. So after do you just leave it like that, or do you put it like x
No,
plus
you leave
16?
it like this. You leave it like this.
Oh, so you don't have to move every like term over?
You want to leave it in as close to standard format as you can get. In fact, that's why it says write the standard equation. Well, the standard equation, this is the format.
Okay.
They may give you a big long polynomial and say, put this in the standard equation. But so far we haven't seen any problems like that. In other words, if I were to expand that out, I'd have x squared plus 8x plus 16 plus y squared minus 2y plus 1 equals 1. And if that's what they gave you to start with, you'd have to work backwards by completing the square or doing various things to get it into the standard format. But this is what you want to focus on at the moment. So number 13, what's it going to be? I'm jumping around just because I can't quite read that one, and I want to make sure they're all the same. The only thing that changes here is the numbers.
Okay. 3, so, x minus 3 squared plus y minus a negative 5, so plus 5 squared equals, what is it? 49.
Okay. And you're quickly going to realize that when that's a negative, the h is positive, and when that's positive, the k is negative, and vice versa. In other words, whenever you have a x or a y plus inside the parentheses, it means that coordinate is going to be a negative. Okay? So in number 16, what's the answer?
Question is, what is the diameter of the circle? 8.
Good. Okay, number 17 starts getting a little bit more difficult, but you still have your standard equation. Now, they do give you two different standards. One is a standard equation at where the circle is at the origin, and then they just give it to you like this. And the other standard is when the circle is not at the origin, and that's when it looks like this. Okay, so anything at the origin, you can use the top one. But the key to all of these is that. So let's look at 17. So what do I know off the get-go?
X is squared.
X
and the
squared,
H and
K are
cross out.
So it's x squared plus y squared. And I don't know r yet, do I? Well, I'm going to figure out r. They're giving us a point on the circle right there that's 0, 6. What does that tell you about that circle? What's its radius?
That it doesn't go across. It's always on the X or Y axis.
Right. So the radius has to be 6, right? If the center of the circle is there, then the radius is 6. So we just substitute that in and we get 36. So there's your answer. X squared plus y squared equals 36. Okay. Let's do another one of those. 18. So here, let's write as much as we know. Start it off based on the center. The center allows you to write everything on the left side of the equation.
1, 2. And the point on the circle.
We'll get to that in a second.
4, 2.
Yeah, let's write as much as we can.
X minus 1 squared plus y minus 2 squared.
equals r squared. Okay? Now, if this point is on the circle, that means I can substitute 4 for x and 2 for y. And that'll allow me to calculate r. So let's do that. You see that? In other words, that's the case with every single function. And it doesn't matter if it's circles, straight lines, parabolas. If you have a point that is on that function, it has to satisfy the function. Okay? So I'm going to substitute 4 for x, and I'm going to substitute 2 for y, and that's going to allow me to solve for r. And then I'll have my formula. So what do I get? 3 squared is 9 plus 0 equals r squared, so r has to be 3. Now, go back into as much of the formula as you had based on their initial, and just substitute 9 here. That's our answer.
So you do center minus the circle on the point, or on the circle?
I'm sorry, what?
You do center minus the point on the circle?
No, the center is not a point on the circle. In other words...
No, I know, but for finding the radius, do you do the point of the center?
I fill in the known x and y values. In other words, I know that if I take a point that is on the circumference of the circle, which is 4, 2, and I plug in 4 for x and 2 for y, that will be a valid equation, especially now that I know what r is. Originally, I didn't know r, okay, but I was able to figure out r by doing that step, by plugging in the known point into whatever part of the equation I've managed to come up with. And that allowed us to solve for r. In other words, as soon as I plugged in an x and a y value, the only unknown in that equation was r. And I figured it out that it was 3, and now I go back into my original equation that I had almost everything except r, and I fill in r. And that's the equation of that circle. Let's do one more of these at least. Let's do 19. We're going to have time just about to do 19. So, how much of the equation do we know? Always do that much. In other words, you know the general equation. Well, they've given us the center, so we now know h and k. So let's write as much as we can.
X plus 3 squared. Y minus 5 squared equals r squared.
Again, they've given us a point on the circle. So what's the next step?
We fill in x, which is 1, and 8, which is y.
I get 1 plus 3 squared plus 8 minus 5 squared equals r squared. Well, that's 16 plus 9 equals r squared. R squared is 25. And notice you don't really need to solve for r. I don't need r. What I need is r squared, and I've just solved for it. So I'm just going to go back to the equation and put in 25. It's very straightforward, really. Circles are, you're not doing general conic sections, are you? Are they doing ellipses also?
Not yet. We just started learning this today.
Okay. The key thing, if you are doing general conic sections, the key absolute thing you want to memorize is the general equation. In other words, the x minus h quantity squared plus y minus k quantity squared equals r squared. If you know the general equation on each conic section, then it really just becomes a question of plugging in, figuring out where the center is. If they give you a point, plugging that in for x and y, and calculating the other variable. Because you always start out with 3 variables on these things. Well, 5 variables. X minus h, y minus k, and r. So there's really 5 variables. Well, they give you 2 of them here, and then they give you enough information to figure out the other 3. And your final answer always has an x and a y in it. You never, in other words, just because at this step I substituted 1 for x and 8 for y, when I finally figure out what r squared is, I go back to this equation, the one that has the x and the y in it. Your standard equation is always going to have an x and a y in it. Okay?
Okay.
You have any questions?
I don't think so.
Okay. What mistake is being made in 15?
They did negative, and it should be positive because you minus and negative.
Exactly, because the center, both coordinates are negative, which means you're going to end up with positives in both places. All right, Quade. I will let you go and talk to you next time.
Okay, bye-bye. Thank you.